Hello students, welcome back. We went through confidence intervals. The next topic is upper and lower confidence bounds. A confidence interval looks like this. We have a best point estimate here, x bar in this case, and then x bar minus margin of error and x bar plus margin of error. And if the confidence level is, say, 95%, as in this picture, then there's 95% of chance in the middle that the real population parameter, in this case mean mu, would come inside this interval. And to the left and to the right, we have outer bound. That's the confidence interval. Now, sometimes we don't really care about one side. Sometimes you're going to consider something like this. If there's a safety issue or something like that, if you're interested in a situation that your structure is exceptionally weak over here, and to the right, nobody cares, exceptionally strong, hey, that's good, nobody cares. Or things like this, if you have to spend too much money, okay, that could be a problem, so you look at only this part. And over here, hey, that's okay, nobody cares. That kind of things are called confidence bounds. So we are not looking at an interval starting from interval left-hand side to right-hand side, L to R, but we are looking for a certain number, lower confidence bound, L, upper confidence bound, U, and that's about it. All right, in a little bit advanced level, people call this confidence level as unbounded confidence interval, and some number to infinity, or negative infinity to upper confidence bound. Some people do it that way, especially in the advanced level, yeah. But at this moment, I'm not going to confuse you with considering confidence intervals of infinity here. So, lower confidence bound, picture like this, only one side. Upper confidence bound, picture like this, only one side. Only lower, only upper. By the way, for traditional reason, nobody calls it left confidence bound and right confidence bound. It's lower confidence bound and upper confidence bound. So lower number goes to the left, higher numbers go to the right, and that's the number line. Okay, all right, that's the theory. Now let's go ahead with an example. Let's come back to this. A certain college selected a simple random sample of 126 commuting students and obtained the students' one-way commute distance. The resulting sample mean was 10.22 miles. Estimate the mean one-way commute distance of all commuting students of this college using the standard deviation of 6.2 miles. We did confidence interval for 95%, and then I think I left 98% confidence interval as for your work. Now find a 95% upper confidence bound and then 99% lower confidence bound. Okay, all right, let's consider that. Upper confidence bound looks like this. Upper, only this part, and the other side, nobody cares. So 95% upper confidence bound. This part, this entire part is 95%. Here I have just entire 5%. Now, let's go back to 95% confidence interval. We have 95% in the middle, and that breaks off the left-hand side to 2.5% and 2.5%. That's confidence interval, all right? Confidence bound, 95% here, entire 5% to the right. That's for upper confidence bound. And if you go to lower confidence bound, it's going to be the other way around. For example, so 95% lower confidence bound will look like this. 5% here, the other 95% over there. By the way, part D was for 99%, so let's go back to default before I forget. Okay, that's the picture, and remember, shading is only to the right-hand side. Now, let's find out this upper confidence bound, which I'm going to call U. All right, here's a picture. X bar is center, and then this is upper confidence bound U. And how do we find out? As usual, you're going to use the formula number 1, n minus center over SE. There you go. N minus center over SE. And end here is, there's only one end this time, U, upper confidence bound. And then minus center, 10.22, over standard error, which is standard deviation 6.2 over sample size, square root of 126. And you have to look up the z-table. Oh, please pretend you don't see it. So n minus center over SE, and then let's look up the z-table. Okay, we want this, right? And am I looking for 5% or 95%? I have to look up 95% because this is left-hand side shading. I mean, this is left-hand side shading. This standard normal table is all about left-hand side shading. And the first page will not do because this is clearly smaller. So the second page, this one looks like bigger, so 95%. Where is 95%? Find the closest to 95%. What do you see? Where do you see? 0.95 something. Do you see it? I have it here. Let me go to the drawing mode. So we have 0.9505, and also I have 0.9495. What do you think? It's a push. And both are in 1.6 row, and then 04 and 05 column, and somewhere in the middle. So how would I estimate this? I'll use 1.645 as an estimation. So 1.64, 0.9495, 1.65, 0.9505. So pretty close to the middle. So I'm going to estimate it as 1.645. It'll turn out that this is pretty good estimation. If you use Mathematica and use 6 decimal digits to work on, you're going to get something very close to this. So the z-score is 1.645, and let's go back to the notebook. There you go. 1.645. Positive 1.645 because, to the right. All right, we have an equation to solve. Let's solve it. Flip the denominator to the other side by multiplying it. So numerator, u minus 10.22, is this right-hand side times the denominator, the standard error. And then flip this center to the other side. It was previously subtraction, so add them all up. Then that's what you get. And what do you have? 10.22 plus the margin of error. In the end, this is what we get. 11.1286, rounded appropriately, depending upon what kind of decimal digits you want. That's the upper confidence bound. The 95% upper confidence bound. Now, what if you want to select not 95% upper confidence bound, but something less, something like, say, 98% confidence bound? You're going to get this kind of picture. 99% confidence, and then 1% there. So this is 99% upper confidence bound that I'm visualizing. So okay, let's go back to 95%, which was the previous picture. And there goes one solution. Now, if you do not like this z-score method, the z formula, and minus center over SE method, there is an alternative way. You see, from the same picture, let's symbolically manipulate. And minus center over SE is a z-score, so u minus x bar over standard error is a z-score associated to, in this case, 95% versus 5%. And to solve it symbolically, then flip this denominator to the other side. So u minus x bar is z times SC, and flip it again. This subtraction, flip it over and make it positive, and what you get? X bar plus z times SC, and this becomes the margin of error. All right, we have a new formula here. X bar plus z star times SC, and z star you have to look up. 95% here, 5% there, and look up 95. And it was pushed between 1.64 and 1.65, right? So you get 1.645 as my z star value. So you have it, and then run your calculation there. Now, if you have lower confidence bound, you'll have to do something similar, but this time you're going to get this value at negative value because I have something in the left-hand side. So typically we have x bar minus z times SE, so that you go to the left, and x bar minus a certain z-score times SE, and you're going to get appropriate value. That's part D of the problem, and that problem is left to the students. Okay, we went through confidence intervals, which are more important, and then confidence bound, which are not as important as confidence intervals, but still pretty important by itself. Now, let me mention one last confusing issue. I really hate this, but please forgive me. This thing was invented far before I was born. There are these kind of things. There's something called upper confidence bound, and let's write like this. The upper confidence bounds versus the upper bounds of confidence intervals. They're not the same, they're different. Likewise, the lower confidence bound, the lower confidence bounds versus the lower bounds of confidence intervals, they are not the same, they're different. Which is which? Let's go back here. Go to confidence interval, and do you see this lower end of this confidence interval? This thing here is called the lower bound of the confidence interval, this thing here, and this thing over there in the right hand side, that's the upper bound of the confidence interval. You have to have a confidence interval in the middle, and this is the lower end, and that's the upper bound of the confidence interval. Now, if you say the upper confidence bound or lower confidence bound, you're looking at this for lower, that's for upper. Look at the picture, they are different. Very, very confusing, isn't it? If I'd been organizing mathematical structure, then I wouldn't have created this kind of terminologies, but it's too late. These things were invented and established far before I was born,